Hi, my name is Oktay. Welcome to today's video about images from the Hubble Space Telescope. In today's video will be galaxy clusters. The telescope was named after Edwin Hubble. His discoveries of the Andromeda galaxy being a separate galaxy and of the redshift increase with distance of the other galaxies have revolutionized our view of the universe. The telescope was launched in April 24th in 1990. This is a picture of the cluster Abell S1077. It contains 220 galaxies, and you can see the images distorted. For example, here. The Abell catalog was made by George O. Abell in 1958, and it contained 2,712 big clusters. This is the phenomenon that's responsible for this distorted image. That's gravitational lensing. It was predicted by Albert Einstein's general theory of relativity. And you can see a mass bent space, and this has a lensing effect. The light from the background source is concentrated to the Hubble Space Telescope. That's why you get a stronger signal. And sometimes you can see the same source multiple times. This is one such example that's called Einstein Cross. In the middle, that's the galaxy G2237 plus 0305. This is the nearby galaxy at a distance of 400 million light years. That's the gravitational lens. And at the background, that you can see four images for the quasar, which is at a distance of 8 billion light years. This is an artist's impression of a quasar. It is a luminous active galactic nucleus which contains a supermassive black hole, and you can see this jet. So the matter spirals in the disk around the black hole. It is heated by friction. That's why it's so bright. And some of the matter falls into the black hole, but some of the matter is ejected with this jets. The particles reach a very high speed. Quasar is also called quasi-stellar objects. This is Abell 1185 at a distance of 400 million light years. Its size is 1 million light years. It contains 82 galaxies, one of which is the lenticular galaxy NGC 3550. This is the cluster Abell 1689 at a distance of 2.2 billion light years. It contains over 160,000 globular clusters. For comparison, the Milky Way has around 150 globular clusters. This is the cluster Abell 1689 at a distance of 2.2 billion light years. This is a newer image of Hubble with an exposure time of 34 hours. And you can see a material stripping of some galaxies. This is Abell 2218, the distance of 2.3 billion light years. It is a strong gravitational lens, and it allowed observation of a galaxy which was in a state of 13 billion light years ago. 13 billion years ago. This is Abell 383 at a distance of 2.3 billion light years. It is a magnifying glass for the farthest galaxy, faraway galaxy, and at an age of less than 1 billion years. So it's very young. This is Abell 665 at a distance of 2.3 billion light years. It is a cluster with richness class 5. which means it contains over 300 galaxies, and it has two subclusters which are in the process of merging. And this big galaxy cluster was used for the calculation of the Hubble constant, which describes the expansion of the universe. This is Abell 520. It's called a train wreck cluster. It is at a distance of 2.6 billion light years. It contains three merging galaxy clusters. In this picture, you can see in blue dark matter. This is Abell 2261. It's another cluster at 3 billion light years distance. And this is one galaxy in the cluster. That's Abell 2261 BCG. BCG means brightest cluster galaxy. The distance of 3 billion light years. There's a large galactic core with a diameter of 10,000 light years. It contains 10 to the 13 stars, which means 10 trillion stars. However, there was no supermassive black hole found yet. This is Abell 2667 at a distance of 3 billion light years. It has a diameter of 2.4 million light years. And this upper left, that's called the Comet Galaxy. And this is why it's called Comet Galaxy, because it has a 600,000 light years long tail. This galaxy was accelerated by the cluster to a speed of over 3.5 million kilometers per hour, and it losing its gas and stars by the cluster's mass. So this means in the future there will be no more gas for future stars in this galaxy. This is the cluster Abell 1758 at a distance of 3 billion light years. It contains two massive subclusters, which are at a distance of 2 million light years. This is a picture from the Chandra telescope of Abell 1758. Two pairs of galaxy clusters are in a process of merging, and this will form a new mega cluster. And the northern pair, clusters in the northern pair already passed by each other about 300 to 400 million years ago, and they have a speed of 3 to 5 million kilometers per hour. This is Abell 1835 at a distance of 3.5 billion light years. It's another galaxy cluster, and it contains a giant elliptical galaxy at the center. This is Abell S1063 at a distance of 4 billion light years. It's a cluster in the center. This cluster contains 51 galaxies, could be 400 more. It's not clear. And the galaxy's mass is 10 to the 14 solar masses. Again, the further galaxies are magnified by this cluster in the foreground. Abell 2744, it's called Pandora's cluster at a distance of 4 billion light years. It is a product of a merger of four smaller clusters from over 350 million years ago. Galaxies make just 5% of this cluster's mass. Other 20% are hot gas, and the majority of 75% is dark matter. This is the Pandora's cluster, another image. The cluster is in blue in this image, and there are scattered stars that drift between the galaxies. And the hot gas is the source of X-rays. In this cluster, 6 galaxies were torn to pieces within 6 billion years. And that's where the scattered stars come from. This is another picture of the Hubble Ultra Deep Field. This is a 3D simulation of the galaxies in space. This is the Sloan Great Wall. It was discovered in 2003. It has a size of 1 billion light years. It's a giant wall of galaxies. The diameter is 1.37 billion light years. The Sloan Great Wall makes 1/60th of the entire observable universe. It has a structure of 5 superclusters, 2 of which have 2,000 to 3,000 galaxies each, and the other 3 superclusters have a few 100 galaxies each. This is one even bigger structure. That's the Clowes-Campusano LQG at a distance of 9.5 billion light years. This LQG means it's a large quasar group of 34 quasars. The length of this structure is 2 billion light years, and the width is 1 billion light years. This LQG group is at a distance of 1.8 billion light years from another quasar group. It's called huge LQG. And this huge LQG structure contains 73 quasars. That was today's video about the Hubble Space Telescope images featuring galaxy clusters and big structures in the universe. Thank you for watching. Have a nice day. Bye-bye.